Now that we know the ins and outs of keyframe operations, let's animate more project components. Go to the Land Cover Task Mode and open the Spruce Fir Forest Ecosystem Editor to the Rules page. The ecosystem is currently set to render on polygons with a maximum slope of 45 degrees. Keyframe this value at 0 seconds. Change the maximum slope to 90 degrees and keyframe it at 20 seconds. View the timeline and you'll see that our ecosystem maximum slope will increase from 45 to 90 degrees over the course of our animation. Close the timeline window, jump to the end of the animation, save the project, and render a main camera preview. It's a good idea to check renders at keyframes and see if the results are the effect you're looking for. It is, so let's move on to the Water Task Mode. Open the Ocean Lake Editor, change the elevation to 1800 meters, and keyframe it at 0 seconds. Switch the main camera view to real-time mode and use the frame slider to advance to just past the point where the camera passes the high-tension tower, about 7 seconds. We'd like the ocean elevation to be visible at the bottom of the view at this point, so right-click and drag up and down. We're still in Move mode, so we're interactively changing the elevation of the active component, in this case, the ocean component. It looks like something around 2,000 meters is about right, so create a keyframe here. Jump back to the beginning of the animation and play it. If we set our keyframes correctly, the water should appear to rise ahead of us as we fly by the island. It may not be clear in the preview, but our ocean rise to its maximum value is not smooth. Open the timeline and you'll see that the ocean elevation rises to 2,000 meters and abruptly stops. We'd like the rate of elevation increase to slow as it approaches 2,000 meters, so select the second key and change its tension to 1. You'll recognize this as the same change we made to the camera latitude and longitude timelines. It's a good idea to check your timelines after creating keyframes and see if the transition across the key is the effect you want. Keep your changes and save the project. Let's move on to the Sky Task Mode, where we're going to animate the moon position. Open the Moon Celestial Object Editor to the Size and Position page and create a key for the position parameters at 0 seconds. Move the moon to where you'd like it to be at the end of the animation and create another key at 20 seconds. The sun is next on our list, so go to the Light Task Mode, open the Sunlight Editor to the Position and Orientation page, and open the Light Position by Time window. Our project is a 3 p.m. light, so let's keyframe that at the end of our animation, or 20 seconds. Change the time to 9 a.m. and create a key at 0 seconds. Save the project, go back to the beginning of the animation, and play it. The sun starts in the east, reaches a noontime position midway through the animation, and drops to the west. This is easier to see in the plan view as the terrain shading changes during the course of the animation. The last component we're going to animate in this project is the High Tension Tower 3D object. Although we can't import animated objects from other programs into WCS, we can animate 3D object position, rotation, and scale, and deform the object by animating vertex position. Go to the 3D Object Task Mode and open the High Tension Tower 3D Object Editor to the Size and Position page. The Dimensions section shows the model to be about 123 meters high. Keep in mind that 3D object axes follow a different convention than terrain axes. For terrain, the x-axis runs east and west, y runs north and south, and z is the elevation. For a 3D object, the x-axis still runs east and west, but z is north-south and y is the elevation. According to the dimensions, this object is about 82 meters wide, 27 meters deep, and 123 meters tall. We're going to animate geographic position and cause the tower to sink into the ground. It will start the animation at its current elevation relative to ground, so create a key at 0 seconds. Frame slide to the last point where we see the entire tower, somewhere around 3 seconds. By this time, we want the tower gone from view, so change the elevation to minus 125 meters and create a keyframe. To make the rate of ascent ease in and ease out, open the elevation timeline and change the keyframe tensions to 1. To expand the timeline where the action's happening in the first few seconds, slide the horizontal axis visible slider to the left. Keep the changes, save the project, jump back to the beginning, and play the animation.